Hi friends, let's continue with polynomials. The question is, show the graph and root of polynomial. We are giving a linear polynomial here, p of x is equal to 2x plus 3. Okay. Note, to plot the graph, we'll say y is equal to 2x plus 3. Okay. Because we have to show the graph on a 2D graph, 2D coordinate system, and you need xy values to plot the graph. And let us fill the table below. Okay. So when x is equal to minus 2, what is y? So if you substitute for minus 2 in here, so you'll get 2 into minus 2 minus 4 plus 3, that is minus 1. Okay. So when x is equal to 2 minus 2, y is equal to minus 1. Similarly, if you substitute x is equal to minus 1, okay, here you will get 2 into minus 1 minus 2 plus 3, that is plus 1. So y is equal to 1 when x is equal to minus 1. When x is equal to 0, this term gets cancelled, 3 remains, so you have 3. Similarly, when x is equal to 1, you will get 2 1s are 2 plus 3 5, and when x is equal to 2, 2 2s are 4 plus 3 7. So we have made this table of x and y points, okay, which is a result of this linear polynomial. Okay, now let us plot them. Okay, so we have plotted them. See this, minus 2 minus 1, the point is here. You go minus 2 on the x-axis, minus 1 on the y-axis, so this is 1 point. Next point is minus 1 minus 1, you go minus 1 on the x-axis, okay, and 1 on the y-axis. We have plotted that point. We have plotted 0 comma 3. If when the x is 0, y is 3, we have plotted that point. Then 1 comma 5, 1 comma 5, we have plotted this point. So all these points, through all these points we can draw a straight line. Remember, a linear polynomial gives you a straight line always. I repeat again, a linear polynomial gives you a straight line. Okay, now what is the root? Okay, what is the value at which y becomes 0? Okay, remember, the polynomial p of x, 2x plus 3, will become 0 at a particular point of x. So to solve that, put y as 0. Y equal to 2x plus 3 equal to 0. Okay, now 3 can be brought this side of the equal to sign. It will become minus 3. And 2x, the 2 which is in the coefficient, can be sent to the denominator. So you will get x is equal to minus 3 by 2, that is minus 1.5. And from the graph also you can see at minus 1.5, the value of y is 0. Okay, can you see this point which has been marked by this arrow? At value of x equal to minus 1.5, the y has become 0. That is, it has crossed the x-axis. Okay, so whenever a graph cuts the x-axis, that is where the root of the equation is. And since this is a linear equation, there is only one root. So root of 2x plus 3, y is equal to 2x plus 3 is x is equal to minus 1.5. Okay, next question. Give a general formula for root of y is equal to ax plus b. Okay, see, you saw y is equal to 2x plus 3. What if we have some value, some constant a, some constant b, and the variable x? Okay, y is equal to ax plus b is the generic form of a linear polynomial. To get the root, set the y equal to 0, which means ax plus b is equal to 0, and b, you bring it to the other side of the equal to sign, you will get minus b, and the a, which is the coefficient next to the x, you push it to the denominator, you will get x is equal to minus b by a. Okay, so generic form of the root of a linear equation like y is equal to ax plus b is x is equal to minus b by a. So x is equal to minus b by a is the root of this equation, and linear equation has only one root. Okay, next question. Show the graph and find the root of quadratic polynomial x squared minus 3x minus 4. Okay, friends, when you upgrade to a quadratic polynomial, the curve no longer remains a straight line, it becomes a parabola. Okay, so how do you draw this parabola? First you have to plot the table. Okay, so to plot the graph, let y is equal to x squared minus 3x minus 4, and for various points of x is the variable, you calculate the appropriate y. Okay, so for example, for we have taken when x is equal to minus 2, when x is equal to minus 1, when x is equal to 0, when x is equal to 1, when x is equal to 2, when x is equal to 3, when x is equal to 4, all these values we have taken. When x is equal to minus 2, you substitute for x in this polynomial. So I have done that rough calculation here at the bottom. So you'll get minus 2 whole squared plus minus 3 into minus 2, because x is minus 2, minus 4. So minus 2 whole squared, you will get a 4, right? 4 minus 4 will cancel. Minus 3 and minus 2 will multiply to give you plus 6. Okay, similarly when x is equal to minus 1, okay, minus 1 whole squared, you will get 1 here. You will get minus 3 into minus 1 plus 4. Okay, sorry, minus 3 into minus 1 is plus 3. 1 plus 3 minus 4, you will get 0. Okay, similarly when you substitute the value of 4, you can calculate it yourself. You will get a value of 0 and all other values. Now if you plot these points, for example minus 2 comma 6, we have plotted minus 2 comma 6 here. Then you have plotted minus 1 comma 0, we have plotted it here. Okay, and when you know the x is 0, y is minus 4. Okay, we have plotted that. Okay, and when x is 4, y is again 0. Okay, so when you connect all these points, you will get a curve, what is known as a parabola. So a quadratic polynomial like x squared minus 3x minus 4 will always give you a parabola. Okay, and a quadratic polynomial like x squared minus 3x minus 4 can have 0 roots, or can have 1 root, or can have 2 roots. In this case it has 2 roots. So y becomes 0, the polynomial becomes 0 at x is equal to minus 1, that is 1 root, and x is equal to 4 also, the y will become 0. So x is equal to 4 is the another root. Okay, so this has to be noted. So we just created a table, we plotted the points in a 2D Cartesian coordinate system. When we join all the points, we'll get a parabola, and this curve cuts the x-axis at 2 points, x is equal to minus 1 and x is equal to 4, and these two are the roots of this equation, x squared minus 3x minus 4. So next question, give us 3 types of quadratic polynomials. See, the 3 types are: one quadratic polynomial, one type is which has 0 roots, example x squared plus 1. Okay, another type is which has only 1 root, for example x squared. Okay, another polynomial which has 2 roots, for example x squared minus 1. Okay, so what we have done is we have created a table like we did the last time for all these 3 polynomials. Y1 is equal to x squared, we have created a table. Y2 is equal to x squared minus 1, we have created a table, and y3 is equal to x squared plus 1, we have created a table, and we have plotted all these points. Okay, so I'll give you an example. When x is equal to minus 2, y1 is equal to x squared is just a squared, right? So you just squared all these values. Minus 2 squared is 4, minus 1 squared is 1, 0 squared is 0, 1 squared is 1, again 2 squared is 4. So we have plotted that y1 here. Can you see? That is the middle one. Okay, that is the middle parabola. Okay, and the middle parabola touches the x-axis only at one point, that is x is equal to 0. So this polynomial which is y1, which is x squared, has only 1 root at x is equal to 0, because this middle parabola which is y1 touches the x-axis only at one point. Okay, how about y2 is equal to x squared minus 1? Okay, if you do the calculation, you will get minus 2 comma 3. So minus 2 comma 3 we have plotted. Then at when x is equal to minus 1, we get a 0 here. Okay, when x is 0, we get a minus 1. When x is 1, we get a 0 again. So this parabola, the bottom one, which is y2, which is x squared minus 1, touches or cuts the x-axis at 2 points, at x is equal to -1 and at x is equal to 1. So these are the two roots of this polynomial. Okay, if you take y3 is equal to x squared plus 1, the top parabola, this one, it never touches the x-axis. So this polynomial has no roots at all. It has 0 roots. Okay, so these are the three types of quadratic polynomials. Okay, next question. Give two methods of finding roots of a quadratic polynomial or a quadratic equation. The two methods are, one is by inspection and factorization, and one is by using the formula. So first what we will do is we will work out few problems which we will solve using inspection, and then we will solve the same problems using the formula, and you will see that the answers will be the same. Okay, so next question. Factorize by inspection and the find roots of sub question 1, 2x squared minus 8x plus 6, sub question 2, 3x squared plus 5x minus 2, sub question 3, x squared plus 7x plus 10, and sub question 4, x squared minus 3. Okay, note, to factorize by inspection, if given ax squared plus bx plus c type, you have to find two numbers such that their product is equal to ac. Please remember, to factorize by inspection, when a quadratic equation like ax squared plus bx plus c is given, you have to find two numbers whose product is ac and whose sum is b. Okay, and then you can proceed with factorization. Okay, so let's take an example. 2x squared minus 8x plus 6. So as we told you, you have to find two numbers alpha and beta whose product is a into c. What is a? It is 2. What is c? It is 6. So find two numbers whose product is 6 into 2, that is 12, and whose sum is minus 8. Okay, now 12 can be expressed as 12 into 1, 6 into 2, 4 into 3, but only one set gives you the sum minus 8, which is minus 6 and minus 2. So you have found two numbers by trial and error whose product, so minus 6 and minus 2's product is 12. Okay, and whose sum minus 6 plus minus 2 is minus 8, whose product is the b value. So once you find such two numbers, this equation can be written as 2x squared minus 6x minus 2x plus 6. So this 8 is broken down into these two subterms. Okay, once you break it into subterms, you can pull out the commonalities. For example, here you can pull out 2x. Okay, between these two terms, you will get common x minus 3, because 2x into x is 2x squared and 2x into minus 3 is minus 6x. Once you pull out 2x, you will get x into x minus 3 here. Okay, to get the same x minus 3, you can pull out minus 2 from these two terms. Okay, so minus 2 when pulled out of those two terms, again gives you x minus 3. Okay, so x minus 3 can be pulled out as a common value, and what remains is 2x minus 2. Okay, from 2x minus 2 again you can pull out 2 as common, so you will get 2 times x minus 3 into x minus 1. So this way, by trial and error, we have factorized by inspection this polynomial 2x squared minus 8x plus 6 into 2 times x minus 3 into x minus 1. Okay, now to find the roots, we want to make this polynomial equal to 0, isn't it not? We have factorized it like this. So 2 into x minus 3 into x minus 1, we equate it to 0, which means either x must be 3 or x must be 1, because if you substitute x is equal to 3, this 3 minus 3 term will become 0 and the whole left hand side will become 0. Or if you substitute x is equal to 1, this 1 minus 1 will become 0 and the whole left hand side will become 0. So x minus 3 or x minus 1 when substituted will make this equation 0. Therefore, the roots of the polynomial are x is equal to 3 or x is equal to 1. There are two roots, x is equal to 3 or x is equal to 1. To verify it, please substitute and see. So you have 2x squared minus 8x plus 6, substitute 3 and see. 2 into 3 squared minus 8 into 3 plus 6. 3 squared is 9, 9 twos are 18, and 8 threes are 24, minus 24 you'll get here, plus 6. So 18 plus 6 is 24, minus 24 you'll get 0. Okay, therefore x equal to 3 is a root. Similarly, substitute 1. 2 into 1 squared minus 8 into 1 plus 6. So 1 squared is 1, 2 ones are 2, 2 plus 6 is 8, 8 minus 8 equal to 0. So this is also a root. So this is how we have factorized by inspection.